Okay, so this is going on page 61. When we are done, we are still graphing, but we're going back to graphing with parent function type stuff with transformations. So we graphed stuff, we did transformations, then we graphed rationals, which really, there were no parent functions, so we had to put puzzles together to be able to graph them. And we're going to go back to a parent function type of mentality here. And look at exponentials. Okay, so there are 2 pages, but this should go quickly because this is not very new to you. You learn exponentials in Algebra 1 and their properties. You do them again and apply things in Algebra 2. And we're doing them yet again now to get us to the next part where we are going. Okay, so your generic exponential function looks like this. F of x equals b to the x power. B being the base. So one of the main differences that the exponentials have is that we've had exponents and parent functions and other functions before, but they haven't been in the exponent. So the variable is up here in the exponent, which means we have to have some sort of number here to even get a parent function graphed. Okay, so there's like an infinite amount of parent functions basically. So if we start with f of x equals 2 to the x power, which is a lot of times what's used as the generic parent function for it. And let's graph some points. So we're going to get our anchor points, and we're substituting them into the parent function here. If I substitute 0 in, I get 2 to the 0 power. What is 2 to the 0 power? 1. Anything to the 0 power is 1. Then my next anchor point, I can substitute in 1. When I substitute 1 in here, I get 2. 2 to the first is 2. If I substitute in a negative 1 right here, what is 2 to the negative 1 power? One half. Thank you. You have to know your exponent rules. It's 1/2. So when I go to the negative 1, I get 1/2. Right? So as I start, so like if I, those are the only 3 points I'm going to plot, but if I was to do 2, I'd get 2 to the second, 2 to the third, 2 to the fourth. And it's just going to keep getting bigger and bigger and bigger, right? So we're heading off as x approaches infinity, f of x is going to approach infinity. As x approaches negative infinity, is f of x going to approach negative infinity? No, I'm never going to be able to cross the x-axis because there's not a number I can substitute in that would give me 0. Does that make sense to you? It can get really, really small. So the bigger the, when I take the reciprocal because of the negative exponent, the bigger the denominator gets, the smaller the fraction gets. So we get really, really, really small, but we don't actually hit 0, which means that I have an asymptote here at y equals 0. And this is what my parent function looks like. Okay. So this says when a is greater than 0 and b is greater than 1, the function is increasing and called exponential growth. Okay, so basically what I was trying to get at here, the wording was bad on these, and I fixed it, and I made it even worse. This one is just totally wrong and doesn't even make any sense. But all that I'm trying to say right here is that if the base b is greater than 1, okay, so if it's greater than 1, then it's going to be increasing, and it's exponential growth. Here, the base is less than 1, but greater than 0, not just less than 1 like this says, and just basically kind of ignore that whole first part of that sentence there. Then we have, let's substitute some stuff in here. I'm going to substitute in 0. So 1/2 to the 0 power is 1. Then I substitute in 1. 1/2 to the first power is 1/2. Then I can substitute in negative 1. What's 1/2 to the negative 1 power? 2. Just take the reciprocal. Okay. So those are my 3 points. You need to go back and review your exponent rules. Go back and review your exponent rules, but I'm not reteaching them again. Okay, that's what it looks like. So again, what I was trying to get at with this sentence is if the base is less than 1 but greater than 0, it's decreasing or exponential decay. All right, what questions you got? So with these, we have all of our bases are rational numbers, but we have what's called a natural base exponential function. And that looks like this. F of x is equal to e to the x, where e is your base. E is a number, just like pi is. It's a constant. Pi is about 3.14159 something. E is an irrational number with an approximate value of 2.718, blah, blah, blah. Okay. Exponential functions with base e are called natural base exponential functions, and many real-world problems are used with e. So, bless you. Should have at least heard of e before. I'm going to play you a little short video that can explain it a little bit better, as you've probably used it in other classes as well, some of your science classes.
We've made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous, but equally fundamental number known to anyone who's taken high school algebra. It's about 2.718281828459045, and so on. And it was first defined by Jacob Bernoulli, but later Leonhard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So, if you stick $1 into a bank account with a 100% interest rate compounded annually, you'll get $2 at the end of a year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then you'll get closer and closer to E dollars. In statistics, it describes the most important statistical distribution, the normal. In biology, it models populations of species through the logistic function. In physics, E describes the exponential decay of a radioactive material. So, while E may not be as famous as pi, it's easily as fundamental and immensely important.
Okay, so that's a little insight into what E is. What it really boils down to is for you to really truly understand what E is, it takes a little bit more math than what you've had. So kind of like you used pi for a long time before you really understood what pi was and what the ratio was, that's kind of where we're going with E here. It'll make more sense to you what it is and why we use it after you get more math under your belt. Okay, so I don't like just saying here it is because I said so, but we're going to kind of go with that. Like, it's fine if you don't fully understand it, just know that you have to use it and it's going to apply in a lot of things that you do. Okay, so we're going to graph our parent function here. So we're going to use, so e to the first power is about 2.718 blah, blah, blah. But for our purposes, we're going to use 2.7 because we have these little tiny grids that we don't have to get that accurate, okay? I'm also going to need e to the negative 1 power, which is 1 over e, which is about 0.3678. But for our purposes, we'll just do about 0.4 because we can't get that accurate anyway. So these are two numbers that you have to know. Kind of like you have to know that pi is about 3.14. You have to know that e is about 2.7 and 1 over e is about 0.4. Okay, there's just two numbers that have to be in your brain. Okay, so let's graph this then. So if I'm going to substitute numbers into there, e to the 0 power is 1 because anything to the 0 power is 1. Okay. If I substitute in 1, that would give me e to the first, which is about 2.7. If I substitute in negative 1, that's 1 over e, which is about 0.4. Okay. And it has the exact same look as if I did 2 to the x. This is basically about 2.7 to the x. So I still have a horizontal asymptote at y equals 0. So my graph looks something like this. So still an exponential. It's still, is this growth or decay? growth because it's getting bigger. What's my domain? All real numbers. Okay, so negative infinity to infinity. My range, where do I start? Okay, I start at 0 and then go to infinity. What's my y-intercept? 0, 1. Okay. My asymptote is at y equals what? 0. So then as x approaches infinity, f of x approaches what? Infinity. As f of x approaches negative infinity, what does f of x approach? 0. Any questions on that at all? Okay. All right. So then over here, we're going to talk about transformations. Now, this is all the same stuff we've been doing with transformations. The difference in what this looks like and some of the other stuff that I've given you is that we've been using C and D here. This uses H and K, but I left it as H and K because I want you to see that the letter doesn't matter. It's where it is and what's happening with it, right? So even in Algebra 2, you might have learned them as H and K. You might see them in something else as H and K. There's some version of it that uses P, Q, R, and S. I don't know why, but I mean, it doesn't really matter. It's about where the number is and what happens with it, okay? But we don't need to rehash all of this because it's all the same stuff. So we have to here identify the parent function and describe the transformation. So the first thing I'm going to do in this mess here that is the exponential, I have to identify my parent function. So the way I'm going to do that is I look at this and I ask myself, what is the base of the exponential part in that? What's the base? 4. 4 is the base of the exponential, right? So my parent function is f of x equals 4 to the x, right? That's part of the parent function. That 4 is greater than 1, so that means it's going to be a growth. It would look like that before any transformations. Okay? Then we have to list our transformations. All right, so I'm just going to go from left to right. I have this negative out here that's not a subtraction. It's being multiplied. So I know that that always means that's a reflection. And that's a reflection in which axis? X or Y if it makes my A negative? X. It's a reflection in the x-axis. Then I have the 3. So the 3 is basically my A, right? And that means that it is a vertical what? Stretch. Good. Vertical stretch by 3. So the next thing I come across is the 4. The 4 is not a transformation because it's the base of the parent function. So he doesn't factor in here. But then I have x minus 2. What does that 2 mean that I do? To the right 2, and the 7 means I go down 7. Okay? Same exact transformations that we've done before. It actually makes these a little bit easier. It's a little bit more obvious what affects x and what affects y, because if it affects x, it's up in the exponent. All right, so let's look at number 2. What is the base of the exponential here? E. That means my parent function is f of x equals e to the x, and it looks like this before any transformations. Then I start with my transformations. The 4/3 is multiplied out in front, so that means it's like my A, which means that is the vertical. Would this be a stretch or compression? Stretch, good, because it's a fraction, but the fraction is greater than 1, so vertical stretch by 4/3. I move on. The E is part of this, so it's not a transformation, but then I have that negative x. That negative means it's a reflection, but in which axis? Good, in the y-axis, because it affects x. And the next thing I have is the 5, and that means I do up 5. Everybody good so far? All right, we're going to skip number 3. Let's go to number 4. What is the base of the exponent here? 3/4. So f of x equals 3/4 to the x power. Right here, those parentheses around that 3/4, very important. If they're not there, the exponent would just go on the 3, and that would make it a totally different question. Okay, so those, you have fractions, you have to put parentheses around it. And since that is less than 1, it's going to be a decay before any transformations. And I say before any transformations because if I reflected it, then it could change it to a growth, or, it could do something else. All right, so start with this negative. I know that that's a reflection in which axis? X-axis. X-axis. Okay, so then I come across the 3/4. That's right here. I don't do anything with that. But then this 3 is being multiplied, and it's for the x. So I know that it's a horizontal what? Compression. Good, because x is still a big fat liar. So it's a horizontal compression by 1/3. The 2 means I do what? Left 2, and the 1 means I go down 1. What questions do you have? Anything? All right. So grab your other piece of paper. We're going to graph some. It's going on page, this will be 62, right? So, all right, so we're going to start with number 1. So the first thing I'm going to do is identify my parent function, f of x is equal to 3 to the x power, and it's going to look something like this. My transformations say that I would go to the right 1, and then I would go down 4. What is the only transformation that's going to affect where my asymptote is? The down 4, okay? If I shift up or down. So I have, if this is an exponential, my parent function has an asymptote at y equals 0. This whole graph gets shifted down 4, so that makes it go to -4. So my asymptote is here. All right, so then I'm going to start with my anchor points. Your anchor points are dependent on your parent function. Okay, when I substitute in 0, regardless of what my parent function looks like, my answer is going to be 1, because it's going to be whatever it is to the 0 power. So I start at 0, 1. From 0, 1, I then do my transformations. I go to the right 1 and down 1, 2, 3, 4, and I'm right here. To determine my next anchor point, I substitute 1 into the parent function. 3 to the first power is 3. So I go to the 1, 1, 2, 3. I'm right here. From here, I go to the right 1 and down 4. Then I'm going to substitute a -1 in here. 3 to the -1 power would be what? 1/3, right? So I go to -1, 1/3. Move to the right. Right here, I move to the right 1 and go down 1, 2, 3. Oh, wait, I'm sorry. It's negative. I moved over 2. Move to the right 1 and down 4. Looks about like that. So then I fill out the info for this. The domain, still -infinity to infinity. The range, where do I start? -4 and go to infinity. My y-intercept. Not only do I have a y-intercept, I actually have it plotted. So since it's plotted, there's no guessing off the graph. It's a fractional piece, but remember we were at -1, 1/3 before we moved over and came down. So that means here I'm at -1, 2, 3. How much is this right here? 2/3. So this is really 0 and -3 and 2/3. It's one of the very, very few times that a mixed number would be okay. My asymptote, is it an x equals or y equals? Y. So it's y equals -4. As x approaches infinity, f of x approaches infinity. As x approaches -infinity, f of x approaches -4. Good. All right. What questions you got? Anything? All right, flip it over. We're skipping the next two. All right, so remember that e to the first is about what? 2.7. E to the negative 1 is about what? 0.4. Okay, those will get me what I need. The base of my exponent here is e, so f of x equals e to the x. Before transformations, it looks something like that. This negative means it's a reflection. It's a reflection in which axis? Y. And then the plus 3 means I up 3. All right. So my horizontal asymptote is where? Y equals 3. Okay. So y equals 3. All right, so I start with my anchor points. E to the 0 power is 1. So I start here at 1. I reflect in the y-axis. I'm on the y-axis, so I can't go anywhere. And then I go up 1, 2, 3. And this point right here. Then I can substitute in 1. E to the first power is about 2.7, so I'm right here. I reflect in the y-axis right here, and then I go up 3, 1, 2, 3, which does put me off my graph, but it's a point I can still put up there just to make sure I can figure things out. Okay? Then in the parent function, when I substitute in negative 1, I get about 0.4. And I'm right here. I reflect in the y-axis, and then I go up 1, 2, 3. About right here. The graph looks like this. Domain here, still negative infinity to infinity. Range, where do I start? 3 and go to infinity. My y-intercept is 0, what? 4. Asymptote is at y equals 3. As x approaches infinity, f of x approaches what? 3. As x approaches negative infinity, f of x approaches infinity. Any questions at all about anything? All right. Good deal. Then let's look at number 5. The base of this exponent is 1/3. So f of x is equal to 1/3 to the x power. Again, parentheses, very important. And since that's less than 1, it would look like this before any transformations. Okay. This negative here means that this is a reflection in which axis? X-axis. The 2 means that is a horizontal what? Compression by 1/2. And the 1 means I go right 1. Where is my horizontal asymptote? 0. We always want to graph that in first. All right, so then I'm using my parent functions to come up with my anchor points. If I substitute in 0, I get 1. Okay? I'm here. Then I reflect in the x-axis, right here. Horizontal compression by 1/2, nothing happens, and then I move to the right 1. And I'm right here. Then I take 1. I substitute it into the parent function. That gives me 1, 1/3. Then I reflect in the x-axis, horizontal compression by 1/2, move to the right 1. Right there. Okay. Then I substitute in negative 1. 1/3 to the negative 1 power is what? 3. So up here at 3, I reflect in the x-axis, horizontal compression by 1/2, move to the right 1. End up right here. So, the point's bigger. Okay? Any questions about where anything came from? Alrighty, so my domain is still negative infinity to infinity. My range, where do I start? Negative infinity. Start at negative infinity, go to 0. Do I have a y-intercept? Yes, one exists. I can't see it on my graph. It's going to be 0 something. I got to figure out what it is. So I have to find f of 0. F of 0 is negative 1/3 to the 2 times 0 minus 1 power. So if I put a 0 in here, that makes that a negative 1. That makes this the negative 2 power. Okay, so that means that if I just do the negative, there's still a negative out there. The negative exponent part of that flips it over, I get squared. 3 squared is 9. Make that negative, I get a negative 9. So 0, negative 9 is my y-intercept. My asymptote is at y equals 0. My end behavior, as x approaches infinity, f of x approaches what? 0. And as x approaches negative infinity, f of x approaches negative infinity. Okay. What questions do you have? All right. One more. Do another E one. So I get f of x is equal to e to the x. So it's going to look like this. The 1/3 means it's a horizontal what? Stretch by 3. The 2 means I do what? Left 2. And the 1 means I go down 1. Where is my horizontal asymptote? Negative 1. Starts at 0, but we go to negative 1. Okay. Start with my anchor points. If I substitute in 0, I get 1. Horizontal stretch by 3 doesn't do anything. And then I move to the left 2 and down 1. I end up right here. My next anchor point, when x is 1, I substitute it in there. I get about 2.7. I'm right here. I have a horizontal stretch by 3. That means you multiply the x value by 3. My x value is currently 1. 1 times 3 is 3, so it changes from 1 to 3. Okay? Then I move to the left 2 and down 1. Then negative 1 is about 0.4. Then I do a horizontal stretch by 3, which puts me at negative 3. Then I move to the left 2 and down 1, about right here. Any questions about where any of that came from? All right, so my domain, negative infinity to infinity. My range, where do I start? Negative 1, and I go to infinity. My y-intercept, 0 something. Mine looks like it's at about 1. Yours may or may not look like it's at about 1 because we didn't actually plot a point. That's just kind of where it went, so I don't get to guess off my graph. I have to go figure it out. I need f of 0. That's equal to e. All right, so if I put a 0 in here, this is 0 plus 2, so 2 times 1/3 is 2/3, and then minus 1. So I get e to the 2/3 power minus 1. If I needed the actual value for that, I would type it into a calculator, but I don't. In this case, I want to leave it exact. So I have e to the 2/3 minus 1. So in general, I don't expect you to know the estimate for this number, but what do you think this value is about? It's about 1, right? Is yours at least about 1, even if it's not right on 1? Mm-hmm. And what this actually is, this is about not that it matters, I mean, you wouldn't have to go find it or anything, but 9477. So if yours looks a little bit less than 1, more so than mine, maybe yours is a little bit more accurate. But that's about, but again, we don't really, it wasn't like we had to go plot it. We just wanted to know exactly what it was. All right, so my asymptote is at y equals -1. As x approaches infinity, f of x approaches what? Infinity. And as x approaches negative infinity, f of x approaches -1. Okay. What questions you got? All right, little side note on Delta Math, because your assignment is in Delta Math. And remember, after you have graphed piecewise functions in Delta Math, all the other graphing is a piece of cake. What it's going to have you do on a question like this is it's going to make you put the asymptote in the correct place, and you have to plot at least 2 points. So I want you to think about this, because it's not always going to necessarily be the same 2 points on the graph. You want to plot the points. If you come across something like this was at a whole number and this was at a whole number, those are the points you want to plot. It's not going to let you plot the ones where you had to estimate the 1/3 on there, okay? So just, it depends on what the graph is, which two. I mean, it's almost always the 0, 1 one that you go with, but the other one, it just depends on how it works out, okay? We good on that? What questions you got? All right, good deal.